Hi everyone, today our video is about how search and execution order in Prolog. In this we say how does Prolog go about answering a query. There are two opposite approaches to attempting to match a given goal to a fact in the database. There are two techniques, one is forward chaining and another is backward chaining. In forward chaining, it is another name is bottom up resolution. In backward chaining, it is known as top down resolution. So what do you mean by forward chaining? Starting with the existing clauses and work forward, attempt to derive the goal. This strategy is known as forward chaining. And start with the goal and work backward, attempt to unresolve it into a pre-existing clauses. This strategy is known as backward chaining. If the number of existing rules is very large but the number of facts is small, it is possible for forward chaining to discover a solution more quickly than backward chaining. In most circumstances, backward chaining turns out to be more efficient. Prolog is defined to use backward chaining. The Prolog searches for a resolution sequences that satisfies the goal. There are two search strategies, forward chaining and backward chaining. Forward chaining derive the goal from the axioms and backward chaining start with the goal and attempts to resolve them working backwards. So backward chaining is usually more efficient, so it is the mechanism underlying the execution of Prolog programs. A forward chaining is more efficient when the number of facts is small and the number of rules is very large. So backward chaining in Prolog is here. We can see the statements rainy settle, rainy roaster, cold roaster, snowy X when rain X and cold X. Backward chaining follows a classic depth first backtracking algorithm. Example, the goal is you see that snowy is snowy is C. So the Prolog interpreter or program explores this tree depth first. Okay, depth first from left to right. It starts at the beginning of the database, searching for a rule R whose head can be unified with the top level goal. It then considers the terms in the body of R as sub-goals and attempts to satisfy them recursively left to right. If at any point a sub-goal fails or it cannot be satisfied, the interpreter returns to the previous sub-goal and attempts to satisfy it in a different way, to unify it with the head of a different clause. The process of returning to previous goals is known as backtracking. So backward tracking search in Prolog, the tree of potential resolution consists of alternating and or levels. And level consists of subgoals from the right hand side of a rule, all of which must be satisfied. And or level consists of alternative database clauses whose head will unify with the sub-goal above. One of these must be satisfied. The notation C equal to X is meant to indicate that while both C and X are uninstantiated, they have been associated with one another in such a way that if either receives a value in the future or it will be shared by both. In this example, the binding of X to cetyl is broken when we backtrack to the rainy X subgoal. The effect is similar to the breaking of bindings between actual and formal parameters in an imperative programming language, except that Prolog couches the binding in terms of unification rather than subroutine calls. So this is about the search and execution order in Prolog. If you have any doubts, you can ask us comments. I will come with the next video. Till then, bye.